Okay, so hello everyone. This is Lance Lian, professor in biomedical engineering at Penn State. Today I'm going to share you a problem in mass transport. So this problem relates to medicine pill. Let's assume that medicine pill is a spherical shape. Okay, so what happened after you take that medicine pill? What are the mass transport going on there? So for this problem, we are interested in model this problem in a spherical shape. So let's say you are going to take a spherical pill, and then after you take this pill in the stomach, the drug from the pill is going to diffuse at all different directions, okay? So let's assume we measured the concentration at two locations. One is at radius equal to R0 position, and we find the drug concentration is C0. And then we measured another location. Let's say this is R0 and this is 2R0. And we find the concentration is 0.2 times C0, okay? So the materials is diffused from high concentration to lower concentration. That's why at R equal to 2R0, the concentration is lower. That's only equal to 0.2 C0. Okay, so for a problem like this, and then they ask you, what is the concentration at, let's say, R equal to 1.5 R0, okay? 1.5 R0 position. So you can see here, the CI, this problem is asking us the CI concentration as a function of position, right? So you give a position and then you know the CI concentration. So basically it is asking us to do CI as a function of position, right? So let's assume for this problem, it's a steady state and it's a dilute system mass transport problem, okay? So for a problem like this, we can set up the equation that is, since it's steady state, so the concentration change with respect to time is 0, right? So what we have is the flux times the area, right? Times the area over the radius is 0, right? So for the flux, we can expand this expression. So for the flux, we can use Fick's law, right? So that is negative d dci over dr, right? And then the area, because it's a sphere, so the area is 4 pi r squared, right? And over dr equal to 0. So from this, we can easily get, because for this equation, you can cancel out 4 pi. You can also cancel out negative d, right? So what you end up with is d over dr times r squared dci over dr equal to 0, okay? So now basically what you have here is you have differential equation that is d, this thing inside over dr equal to 0, right? As we know, only when this inside stuff is a constant number, then you do the derivative, then you got 0, right? So basically, this is telling us that the inside part of this equation is a constant number, right? So we can assume that r dci over dr is a constant number. Let's say this number is a, okay? So basically what you got is dci over dr equal to a times r to the power of -2, right? So the general expression of ci is equal to negative a over r plus b, okay? So basically you have two unknowns that you need to solve. So the good news is we already have the two boundary conditions, right? So the problem already gave us two boundary conditions. As long as we put the two boundary conditions into this equation, we can solve for a and b. And then we apply r equal to 1.5 r naught. We can solve the concentration, right? So we can do this together. So let's apply the first boundary condition. So basically what we got from the first boundary condition is, so what we got is C naught equal to negative A over R naught plus B, right? And then from the second one, we got 0.2 C naught equal to negative A over 2R naught plus B, okay? So you got two equations, right? And then you use equation, the top equation minus the bottom one, right? So you got 0.8 C naught equal to, so you got -1 plus 1 over 2, right? So you got negative A over 2R naught and B canceled, right? B canceled. So basically what you got is, what is A? A equal to negative 2 times 0.1.6 C naught times R naught. Okay, so basically is 1.6 C naught R naught. Okay, that's A. That's A. Okay, and then we apply A into this first equation, and then we got B, right? So you got C naught equal to, so negative and negative canceled. So you got 1.6 C naught R naught over R naught plus B, right? And then you got B equal to, and then here the R naught and R naught canceled, right? So these two canceled. So basically you got B equal to 1 minus 1.6, right? So it should equal to negative 0.6 C naught, okay? So that's B. And then we apply this into the equation. So Ci should equal to negative canceled, right? So you got 1.6 C naught R naught over R plus B, right? B is 0.6 C naught, okay? So that's let me highlight this. So that's the final answer. And then for solving this problem, now it's very easy, right? So you basically, what you do here is you're going to put 1.5 into it, right? So the Ci should equal to 1.6 C naught R naught over 1.5 R naught minus 0.6 C naught. Okay, so what do you got? You got 1.6 divided by 1.5, that is 1.07, okay? And then 1.07 and minus 0.6, you got 0.47 C naught, okay? So that's the final answer, okay? Let me highlight one more time. So the final answer is the CI at this position is 0.47 C naught. Okay, so I hope this video helps. Let me know if you have any questions. You can make your comments below. Okay, yeah, bye-bye.